Figure 9.1 shows a 12-volt battery connected in a circuit containing A, B, C, and D resistors. Each resistor has a resistance of 6 ohms, so they are all identical in resistance. Calculate the combined resistance of A and B. So you will notice A, B, and C are connected in the parallel part of the circuit. However, A and B are connected along the same branch. So what you can do in that case is simply add the resistances together. So we have 6 plus 6 will give a total of 12 ohms for this particular bit here. I'm just bracketing in red. Part 2, resistors A, B, and C. The total resistance in a parallel setup is calculated using the reciprocal, or in other words, it's expressed as a fraction. So what I need to do is write this expression. So 1 over TR, where TR is the total resistance in the parallel part, is equal to 1 over R1 plus 1 over R2. And we're going to call C R2, and we're going to call this top branch in brackets there R1. 1 over R1 becomes 1 over 12, because A plus B was 6 plus 6 is 12, so 1 over 12 for that branch, plus 1 over 6 for the other branch. So to work out TR, I simply switch the fractions, so that goes to the top. I have to do the same to the other side. So 12 over 3 is equal to TR over 1. So therefore, TR equals 12 divided by 3 is 4. So 4 ohms is the combined resistance of A, B, and C. Finally, part 3, resistors A, B, C, and D. So you will notice D, which I've just circled, is not in the parallel part of the circuit. It's outside in the series part. So to work out the total resistance, I add the resistance from the parallel part, A, B, C, which come to 4 ohms, to the resistance of D, which at the beginning of the question tells us is 6. So 4 plus 6 equals 10 ohms. So the combined resistance of A, B, C, and D for this circuit is 10 ohms. Part B, calculate the current in the battery. So I need to use my formula, V equals IR, rearrange to give I equals V over R. The voltage is 12. The resistance, the total resistance in the circuit is 10. So 12 divided by 10 is 1.2 amps. Finally, the energy transferred from the battery to the circuit in 50 seconds. So for this one, we need to bring in a different formula, which is energy transferred is equal to power times time taken. And I'm just going to write the power formula as P equals IV, power equals current times voltage. So I need to work out the power first. Then I can plug that number into the E equals PT formula and get the energy transferred in joules. So power equals current times voltage. So the current is 1.2 times 12 gives 14.4 watts. What that means is 14.4 joules of electrical energy is transferred every second, because 1 watt is 1 joule per second. So the total amount of energy transferred in 50 seconds is, you just times it by 50. So that's where the E equals PT formula comes from. So let's go and put that in. Gives a total of 720 joules. So 720 joules of energy is transferred from the battery in 50 seconds.